Alright, so you're looking for some help on your radicals homework. That was probably due like months ago, or at least a month ago. But anyway, I'll walk you through it. It's been a while since we talked about this in class, so I understand if you're looking for some help, this is why I'm making the video. We'll cover everything you need. I probably won't do every single problem just for the sake of time constraints, but I'll probably at least do one or two of each type. That way you sort of have enough assistance to hopefully get you through the rest of it. Okay, so let's begin. Number 1, 2, and 3 are all asking for the domain of each function. Now the domain, basically, let's just kind of cut to the chase. The domain is focused on what's inside the radical. So I'm just looking at the x plus 6 that's inside the radical. This thing that's inside the radical has to be greater than or equal to 0, since theoretically we're not supposed to be able to take the square root of negative numbers. So if I take this and I set it greater than or equal to 0, well then I'm assuring myself that x plus 6 or whatever is inside the radical will not be negative. So I take it, I set it greater than or equal to 0, and I will just solve for x. So let's subtract 6 on both sides, and we'll have x greater than or equal to negative 6. And there's our answer. That is our domain. Our domain is all the x values that are greater than or equal to negative 6. I'll do number 2 as well since it's quick and short, but number 3 will follow sort of the same process, but we're looking at just what's inside the radical. I know there's nothing else in this equation, but if there were, it wouldn't matter. I only need to know what's inside the radical. So negative 3x. That has to be, again, greater than or equal to 0. They all always have to be greater than or equal to 0. So take what's inside that radical, set it up, greater than or equal to 0. This is how we're going to start these problems every time when I'm searching for the domain. And I'll just solve. So I'm going to divide by negative 3. Okay? Now there's a catch to this because I'm working with inequality symbols, and I just divided by a negative. That means I have to flip my sign. That's the only time you have to flip your sign is when you divide by a negative, but we did it, we flipped our sign, la-di-da. Now 0 divided by negative 3, keep in mind this is division. 0 broken into negative 3 parts is still going to be 0, so our answer is x is less than or equal to 0. Alright, so let's kind of continue moving on. We're going to simplify now. Alright, now these are all kind of the same but a little bit different. They kind of build on themselves, but it all comes down to pretty much 3 things, and we'll discuss what those are in a moment. Well, let's begin with number 4, square root of 75. Now 75 is not a perfect square. Am I not writing on this? No, I'm not. 75 is not a perfect square. Okay, which means if I were to try to type it in the calculator, give me some sort of decimal, that's not what I care about. I want to simplify my radical. I still want my answer to be in radical form. Alright, now I'm going to list down the perfect squares. 2 squared is 4, 3 squared is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36. Right, you keep going, 7 times 7 is 49, 64 is 8, 81, 9 times 9, 100. You can keep going, but I think this is all we're really going to need for this. Maybe not even that many. Alright, but that helps because what I'm trying to do is I want to figure out, since 75 is clearly not one of those numbers, it's not a perfect square, I want to know which of those perfect squares, 4, 9, 16, 25, etc., which one of them can divide into 75. So if I wasn't sure about this, what I would do is I'd take my calculator and I would just go 75 divided by, and I would just start plugging in some random number, 64, and see if it works, see if I get something that's not a decimal. Okay? And if that didn't work, then maybe you could try the next one, maybe, like 49, right? And just keep trying something until you find something that works. If you type in your calculator, do 75 divided by 25, you realize that you're going to get the answer 3 out. So that tells me that 25 and 3 are going to work. So I'm going to break the 75 up into 2 radicals. I'm going to break it into square root of 25 and the square root of 3. Because technically, 25 times 3 is equal to that 75. Okay. So again, if you weren't sure which of these you'd be able to use, just take your number, whatever it is, divide it by whatever you see here, and find one that works. Okay? So anyway, I found 75 and 3. I'm going to do this. Nope. Oops. Okay, anyway. Alright, so now I'll take the square root of these. Now, the square root of 25, 25 is, as we know, a perfect square. So the square root of 25 is 5. And the square root of 3 is going to be left as my remainder. Alright, so when you break these two up, you have two parts. You have a perfect square, and then you have a remainder piece. So the perfect square will simplify really nicely, like the square root of 25 did. And then the remainder kind of gets stuck and left over as a remainder. But that's our final answer, 5 square root of 3. Alright, so if I wanted to move on to number 5, I've got variables, and that's okay. Sometimes maybe, in some people's opinions, a little easier. Alright, but what I want to do, since I see 3 variables, x, y, and z, is the first thing I want to do is separate them all apart. The square root of x to the 6th power, the square root of y to the 9th power, and then the square root of z. And I'm going to simplify these one at a time, basically treating it as if it was 3 different problems. Alright, so how can we do these? I taught this differently in class, but I want to go ahead and teach it sort of a, in my opinion, maybe a little easier way. So what I want to do, let's just focus our attention on x to the 6th for a minute. Okay? Square root of x is 6. That, basically, let me go ahead and write out all those x's. 1, 2, 3, 4, 5, 6. That's the same thing as the square root of x to the 6th. And I just want to find all the pairs that I can find. So, there's a pair, and there's a pair. So how many pairs did I get? I had 3 pairs. Which means the square root of x to the 6th is going to be x to the 3rd. It's not the square root of x to the 3rd, okay? It's just a plain old x to the 3rd. Alright, there are no x's left inside the radical, like there were no extra x's that did not have a pair. So there is no square root remaining, or there is no x's left inside the square root. Alright, so I'm going to erase this, but I'll write my answer back down. We'll have at least for the first part, the square root of x to the 6th is going to be x to the 3rd. Now I want to do the same thing, but I want to do it with the y to the 9th. So let me take my y to the 9th and write out all my y's. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright. Same thing, I just want to find the pairs. However many pairs that I find will be the exponent, and that's pretty much it. So, square root of y to the 9th. So I have a pair here, another one, another one, another one. So I have 4 pairs, which is going to make this y to the 4th. However, you realize, hey, you know what? I have a leftover y here. That one gets stuck and stays inside the radical. It did not have a pair, so it could not come out of the radical, and it gets left over. Like I said, that's the remainder. So we're going to replace that. We're going to have a y to the 4th, square root of y. Okay, and now the square root of z. Well, if I were to try to write down the square root of z, you're going to realize that, well, if I try to break it all up, like, that's, oh, it's an x, it's a z, right? Not an x. Go ahead. Alright. Write out all the z's. Well, there's only one z, and again, I want to try and find the pairs. Well, there is no pairs, so that really doesn't change, right? Because there are no pairs of z's, it's just a single z. So this is essentially my final answer, but let's clean it up a little bit. I can write my answer as x to the 3rd, y to the 4th, and then the square root of y, z. So since y and z are both inside the square roots, I can go ahead and put them inside the same square root. They don't have to be in separate square roots. Alright, so number 6 is basically the same thing as the previous 2 questions. Break everything up. Square root of 28, the square root of f to the 3rd, square root of g to the 12th, the square root of h to the 5th. Now, the 28, just like the 75 from number 4, is not a perfect square, but we're going to try and break it up into 2 numbers. What 2 numbers? Well, that's what we got to figure out. Let's take our 28, let's divide it by any of these perfect squares. 4, 9, 16, 25, 36, etc. Well, since, 36 is bigger than 28, I won't even try wasting my time using anything bigger than that. So I can try starting with 25 and seeing if it works. Now that wouldn't work. It would give me a decimal. So I could try another one. I could try 16. And I would realize that that doesn't work either. And eventually, if you try enough on your calculator, 28 divided by 4 would work. 4, again, is a perfect square, which is why I'm using it. 4 times 7 is going to be equal to 28. So if you divide it by 4, you get the answer 7. And so we're using the 4 and the 7. Now the square root of 4 is 2, right? Because that's the perfect square. It simplifies really nicely into just 2. And the square root of 7 is a remainder and does not change. So that's the simplified version of the square root of 28. It's 2 square root of 7. Now f to the third. I know I'm kind of writing all over this, but f to the third, same thing. It's my variables. Let's write it all out, and let's mark my pairs. So that's 3 f's. All right, here's a 1 pair. And that's all the pairs that I can have. So that's just f to the first power. And then I have 1 leftover f inside the square root. So again, that leftover 1 stays inside the square root, whereas the pairs could come out as 1. So we're going to have f and then the square root of f. Now g to the 12th, I'm going to need my eraser here so I can make some more space. G to the 12th, let's write out 12 g's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, I think that's 12, right? Yes. All right. So again, find all the pairs. So here's a pair, 2, there's another, there's another, another, there's another. All right, so how many got? 1, 6 pairs. So that's g to the 6th power. Are there any leftover g's? No, I used them all up. So this is just a plain old g to the 6th power. And then lastly, the h to the 5th power. After doing this enough times, you probably can do without having to write them all out. But, if you're ever unsure, writing them all out is always helpful. So 5 h's, I've got 1 pair, I've got 2 pairs, so that's h to the 2nd power. And then I have just 1 h left over, so it's going to stay inside the square root. All right, again, the number of pairs is the number for the exponent. So like I had 6 pairs with the g, that's why it's g to the 6th power. That 6 in the exponent is recognizing how many pairs I have. So the h to the 5th, it comes out to be h squared and then the square root of h. So we have pretty much our final answer all written out right here, but we're going to clean it up a little bit because it's a big mess. Anything that's not inside the square root, we're going to write first, and then anything that's left inside the square root, we'll write last. So I've got 2 that's outside the square root. I have an f that's outside the square root, right? I've got g to the 6th that's outside the square root, and I have h squared that's outside the square root. And what's inside the square root is I have a 7, f, and an h. So there's my final answer, all cleaned up. It's basically the same thing, but I just made it look a little bit more presentable. All right, so let me kind of clear off everything I've got on my slide right now, or my screen. All right, just so I have a little more room. The final 3 problems that you see here, it's 7, 8, 9. I'm going to just quickly breeze through them, but it's pretty much you get the point. Just separate the top from the bottom, square root of 7 and the square root of 25, and then simplify those parts. So, for instance, the square root of 25 is a perfect square. That'll come out real nice. Number 8, break them up again. So break up the top. We'll have x to the 5th and z. I'm going to go ahead and break up the z as well, because I'll eventually have to do that anyway. And on the bottom, I have the square root of y to the 6th. So, just like you did it with the variables in previous problems, right, you're going to do it exactly with those as well. And then just put them all back together in the end. And at number 9, before you do anything, simplify 6 over 27. This is a fraction, and both of these are divisible by 3. So I would reduce that fraction first. 6 divided by 3 becomes 2. 27 divided by 3 becomes 9. So let's write this as 2f g to the 7th over 9h squared. So, oh man, a little bit too much there. G to the 7th, and then h squared. All right. And then, again, you can break everything up. The square root of 2, the square root of f, the square root of g to the 7th, over the square root of 9, square root of h squared. And just do all those pieces individually. Some of them you can do, some of them you can't do. For instance, the square root of 2 cannot change, so it would be left like that. The square root of f cannot change. You can, however, simplify the square root of g to the 7th. You can simplify the square root of 9, and you can simplify the square root of h squared. I'll leave that for you guys to be able to do, and I'm going to move on here. All right, and number 10, just again, try to make this fast. An apartment manager needs to order wallpaper for order. All right, the function here gives the amount of border needed in feet, and here's the amount of border I'm using. So this is the amount of border I'm using. This is an equation that gives the amount of border I need when I know the square footage, which is x. I know the square footage. It's x. So my square footage is 100. The square footage is x. So I'm going to use 100 for x. We'll have 640 square root of 100. And you guys just simplify that and tell me what the answer is. If I move on to October 10th homework. Okay. All right, now this is adding and subtracting. So if they're like radicals, you can add them together. If they're not like radicals, you can't. Or at least you'll have to simplify it first. So number 1, 9 square root of 7 and 4 square root of 7, they both are the same radicals. So we can go ahead and combine them. They're like terms, essentially. So 9 plus 4 would make 13 square root of 7. And that's it. Same thing with number 2. These are both like radicals, a square root of 5 and a square root of 5. So you can combine them together, negative 10 plus 2. Number 3, notice the square root of 2 here and the square root of 2 here. These two terms are like terms, and you can combine them. The square root of 2x is not a like term, but you can bring it down and just not change it. Okay? So again, I'll let you do that. Now number 4, these are definitely not like radicals. Square root of 108 and square root of 75. Completely different numbers inside their square roots. So what do? Well, you simplify them, just like you saw up in previous problems. You know, 108 is not a perfect square. You remember when I had all those numbers written down? 4, 9, 16, 25, 36, 49, 64, 81, 100. All right, the next one will be 121. All right, 108 is not a perfect square, so you break it up. You find two numbers that multiply to make 108. One of those numbers has to be, though, one of these perfect squares. So again, you would take your 108 and just start dividing any of these until you find something that works. Again, start with something that's larger and then work your way down. So I might start with 100 or 81 and work my way down until I find something that works. If you do that enough and you do 108 divided by 36, you realize that that works. It'll give you a value of 3, so you're going to use the numbers 36 and 3. So the square root of 36, that's a perfect square, that's a 6. And the square root of 3 is our remainder, and that's the part that doesn't change. Alright, but we're not done yet because we still have the square root of 75. We just did that previous problem, right? We broke it up into 25 and 3. And again, the square root of 25 is a perfect square, that's why I'm using it. That simplifies nicely into 5. And then the square root of 3 is left as a remainder. And now, these are like terms, and you can combine them, 6 plus 5, to make an 11 square root of 3. So, you're going to have to do that with number 5 as well. You know, break up your 28 into two numbers, and simplify that. Make sure you don't forget the x, and do the same thing with the 63 here. Try to break that up into two numbers as well. Just like number 4 did, you'll see that once these are simplified, you'll be able to combine them. Number 6, I cut it off a little bit there, but there's no math you really need to do except just look for like terms and combine them. And notice that 4 minus 4 is going to end up being 0. It's not 1, so keep that in mind. Alright. Number 7, if you want to do this one, you could just basically plug these numbers in your calculator. Plug these numbers in your calculator and see what they give you as decimals. Okay? and then write them back in radical form from the biggest to the, or from the smallest to the biggest. So I don't know what these numbers were, but if this came out to be like, I don't know, 6.3 or something, and this one came out to be like 7.2, and this one was like, I don't know, it's not right, but like 9 or something, then you would write them in least to greatest. So this would have been the smallest one, so you'd write the 3 square root of 8 first. This one would have been the next smallest, so you would have written the second, 4 square root of 2. And this one would have been the biggest, so you'd write it as square root of 50. Alright, so just converting it to decimal form only helps you identify, and that's not the correct answer, by the way, I'm just giving you an idea of what it would be. But converting it to decimal form at least tells you which one's smaller and which one's bigger, and then you can just at least, just go ahead and write them down from whichever was the smallest to the biggest. Alright, the map on the right says, we want to find out how far this person traveled. I don't necessarily know where they began, but let's say that they started here, and then they went this way. Well, then they went square root of 28 miles. Don't know why they have to write as square root of 28, but they did. And then they went this length, which is 2 square root of 7, so you tack that on, you add that to it. Then they went 2 miles, then they went square root of 112 miles, and then they went, last but not least, 3 miles. So you have this long equation, which I should have written down over here so I had more room. And all you got to do is basically simplify each piece and then combine like terms. Alright? Anyway, write them all out and then simplify. You'll have to simplify the square root of 28 and the square root of 112. Everything else is already simplified. But once you simplify these two, then all you have to do is combine like terms. Okay? Alright, now for multiplying, the square root of 15 and the square root of 6, you can multiply these inside the same radical. So when you're multiplying radicals, you can just multiply them together, but make sure they're inside the radical, and then you can combine or simplify it at the end. So 15 times 6, that would be the square root of 90. But that's not my final answer. That just helps me get halfway there. But now I want to simplify my answer. 90, as we know, is not a perfect square. Remember my perfect squares? I've written them out 3 times already in this video. But take these and try to figure out which of them can divide into 90. If you do that enough, you'll realize the square root of that 9 and 10 would work. So the square root of 9 and then the square root of 10. Square root of 9 simplifies, it's just the value of 3, and the square root of 10 is left as the remainder. Alright, number 2, you have 3 square root of 6 times 3 square root of 6. That's what happens when you have 3 square root of 6 squared. And you multiply the outside parts together, and then you multiply the inside parts together. So 3 times 3 is going to make 9, and then 6 times 6 is going to make the square root of 36. So the 3's multiply together, and they give me the term on the outside. And then the 6's can multiply together, and they give me this part that's on the inside of the radical. Of course, I'm not done because the square root of 36 is simplifiable. The square root of 36 is 6, so really I've got 9 times 6, which comes out to 54 as my final answer. And number 3, you do the same idea. Take what's inside the radicals and multiply them together. Take what's outside the radicals and multiply them together. Now, the only thing outside the radical is 4, so it doesn't really have anything to multiply with. But I can multiply my 7x and my 20x together since they're both inside the radical. So 7 times 20 would give me, I think, 140, and x and x would give me the x squared. So that's me multiplying them together. All you have to do now is simplify. Again, just carry your 4 down. Don't worry about it just yet. But I would simplify the 140 and then the square root of x squared. Just like I've been talking about before. You're going to have to break the 140 up into 2 numbers that multiply into it. Make sure you find one of them that is a perfect square. And then simplify the square root of x squared as well. Now for number 4, 5. From 4 and 5, you're just distributing. Square root of 8 times the square root of 12. Again, since they're both inside square roots, we just multiply the 8 and the 12 together. That would be, I think, the square root of 96. And then you multiply the square root of 8 times the square root of 2, which would make the square root of 16. And then you'd simplify those two parts. So 16, this is a perfect square, and we'll simplify into a nice whole number. The square root of 96, not so much. You'll have to break that one up and simplify those parts. Number 5, you'll have to FOIL it. So 4 times 2, then 4 times square root of 3. I'll just start you off here. 4 times 2, I can multiply them. It's going to give me 8, of course. Now 4 times the square root of 3. Now 4 is not inside a square root, so I can't simply just multiply it with 3. I'm not going to have 12 in this at all. I'm just simply, because it is a minus sign, let's keep that in mind, a negative square root of 3. We're going to have a negative 4 times the square root of 3. So 4 times the square root of 3 really is just 4 times the square root of 3. I can't actually multiply 4 with 3 because 3 is inside the radical and 4 is not. So then if I try to distribute the square root of 3 times 2, the same thing is happening. 2 is outside the radical and 3 is inside. So I can't multiply them together. I simply will just have 2 times the square root of 3. Okay? And then lastly, you have the square root of 3 times the negative square root of 3, making this negative. And then this, because they're both inside the square root, you can actually multiply them together, right? The 3 is inside the square root, and the 3 is inside the square root. So you actually can multiply them together and make the square root of 9. Now you have a little bit of work to do. You have some like terms that you can combine. You have this that will simplify, because it is a perfect square. And once you simplify that, you'll be able to combine those like terms as well. 8, and then whatever this number is. All right. Number 6, I'm going to bypass for now. Just, again, try to save a little bit of time on this. I'll leave links to other videos in the description. I'll help you out with that. If you're going to solve square root of equations, radical equations, the opposite of taking the square root, like square root of x, the opposite of that is x squared. So taking something to the second power, squaring it, so to speak, is the opposite of square rooting something, right? The square root of 25 equals 5, but 5 squared equals 25. So they're opposite operations, they're inverses. So that's how we're going to solve these. I want to get this x by itself, but it's being square rooted. Well, if I want to get rid of that square root, I got to think to myself, well, what's the opposite of the square root? How can I undo that? Well, the opposite of square rooting something is squaring it. So that's going to cancel out the square root sign and leave just the x, no longer having the square root. But I have to make sure I do that to both sides, because I do have to keep the equation balanced on the left and right. So that's going to give me 11 squared, which is 121. All right? So my process in this is thinking outside the radical, then the radical, and then the inside of the radical. That's my approach to this every time. So if you're trying to figure out what order to do these in, do it in this order. Anything that's outside the radical, take care of first, then take care of the radical, then take care of what was inside the radical, if there is anything to take care of in there. So here, I noticed that of course the 5 is outside the radical. However, the 5 is not on the side of the x, so I'm not really concerned about it. I'm only concerned when I'm talking about this stuff here. I'm talking about the side that has the x on it. So that's the left side. The x is inside the square root, inside the radical, but 3 is not. So I'm going to move this 3 first because I do want to solve what's outside the radical. So what am I doing with 3? I'm dividing by 3. The opposite of dividing by 3 would be to multiply by 3. So multiply both sides by 3, that'll cancel it out. I'll have the square root of x equal to 15. Alright, now there's nothing left outside the radical on the left side, so I just got to get rid of the radical now. We just solved the opposite of that is squared. So I'll have x equal to whatever 15 squared is. I think it's 225, but double check the calculator. Number 3, same process. Focus on the side that has the x, okay, so don't worry about that 11. And work with outside the radical, then get the radical, and then get what's inside the radical. So on the left side, what's not inside the radical? What is on the outside? The 5. So I want to take care of it first. I'll subtract my 5 and move it away, and we'll have the square root of 3x equal to 6. Alright, now notice the 3x, the 3 particularly, is inside the radical. I'm not going to worry about that yet because I have to get rid of the radical now. Right? I've done what's outside the radical, but now I need to do what's the radical itself. So to get rid of the radical, of course, you square it. Then that'll leave us with the 3x equal to 36, because 6 squared is 56. Now I'll take care of what was inside that radical. This is the time I'll take care of the 3. So I'll divide by 3. I'll have x equal to 12. All right? So remember to go in that order: outside the radical, then the radical, then inside the radical. Okay? And number 7, last and not least, you have radicals on both sides. So square both sides to get rid of the radical sign and just solve the equation like normal. Alright, that's going to cover it for this video. It took really long because it was a whole week's worth of homework I had to cover for you. But hopefully it helps even just a little bit. Okay? So I'll see you in another video if you have any other work you need to make up. Alright? Ciao.